Hello and welcome to the next lecture in our programming course. In this lecture, we are going to start getting into the nitty-gritty and the details of R. In particular, I am going to talk about different data types that are used in R and some basic operations on those data types. So first, it's important to kind of get the language right correctly. So all of the things that you manipulate in R, all the things that we encounter in R are what might be called objects. Objects can be all different kinds, can contain all different kinds of data, but everything in R is an object. So R has 5 basic atomic classes of objects. So these are kind of very low level or basic classes of objects that are character, numeric. So these are like real numbers or decimal numbers, integers, complex numbers, and logicals. So logicals are just true or false type things. And so the most basic object in R is called a vector, and a vector can contain multiple copies of, for example, of a single type of object. So you can have a vector of characters or a vector of integers. One thing you cannot do with a standard vector is have mixed types of objects. You cannot have a vector of characters and numerics, or numerics and integers, or integers and logicals. Everything in a vector has to be the same class. Of course, with any grade rule, there is always an exception, and this one is no exception. So in this, with vectors, there is one type of vector that can have multiple different types of classes, and that is called a list. So a list is represented as a vector. It's a sequence of objects, but each element of that vector can be different, can be an object of a different class. So for example, you can have a list that has a character, that has a numeric, it has a logical, and so on. You can have a list that's inside the list, and one element of the list can be a data frame. So one element of the list can be anything, and that's an actually what makes list so useful. So the list is the one exception to the general rule that vectors can only contain elements of the same class. So you can create an empty vector with the vector function, and the vector function has two basic arguments. The first argument is the class of the object, so the type of object that you want to have in the vector, and the second argument is the length of the vector itself. Perhaps the most important type of object in R, of course, is the number. So numbers in R are generally treated as what are called numeric objects. So pretty much all numbers are treated as double number precision real numbers. So even if you are looking at a number that's like 1 or 2, or things of those numbers as numeric objects, there is a way to explicitly say you want an integer, and you can specify the capital L suffix there. So for example, if you just enter the number 1 in R, that gives you a numeric object, but entering 1 with a capital L next to it explicitly gives you an integer. This distinction is not very important right now, but it will become more important later. There's also a special number called inf, which stands for infinity, and inf is like a real number. It can be used in calculations, and you will get the expected result. So for example, if you take 1 divided by 0, you will get infinity, and if you take 1 and divide it by infinity, you will get 0. So emphasis special number, and you can also have minus infinity too. There's another special value called nan or nan, and this represents an undefined value, so you can name it as not a number. So for example, if you take 0 over 0, that's not a number, it's not defined, so you will get a nan back. Nan can also be thought of as a missing value, but we will talk a little bit more about missing values a little bit later. So another thing that comes with each object in R is an attribute. So not every object in R necessarily has attributes, but attributes can be a part of an object in R. Some of the most common types of attributes that we will encounter are names, or dim names, or dimension names. A dimension, so a matrix will have dimension. For example, it will have a number of rows and a number of columns. If you have a multi-dimensional array, you will have more than 2 dimensions. The class of the object, so every object will have a class. So for example, numeric objects, their class is numeric, and integer objects, their class is integer. Every object also has a length. So for a vector, it's quite simple. The length of the object is just a number of elements in the vector. And then there may be other user defined attributes or metadatas. So these are things that you can define separately for an object using various attribute functions. There is a general function called attributes, which allows you to set or modify the attributes for an R object. Now we will discuss vectors and lists data types. So the C function is another function that can be used to create vectors of objects, and you can think of C as standing for concatenate because it can be used to kind of concatenate things together. So for example, I can create an object called X by concatenating 0.5 and 0.6, and that will give me a numeric vector of length 2. For the first element is 0.5 and the second element is 0.6. In the second example here, I have got a logical vector. We are concatenating through true and false. So shorthand for true and false, you can use T and F, capital T and capital F. So these two lines give you the same object. You can create a character vector by concatenating a bunch of characters. You can create integer vector by creating a sequence with colon operator, and you can also create a vector of complex numbers where the I is a special symbol which indicates the imaginary part of the complex number. So using the vector function, you can also create a vector of a certain type and a certain length. So here I am going to create a numeric vector of length 10, and by default it will initialize the vector with a default value. For numeric vectors, the default value is 0. So what happens if you create a vector and you mix two different types of objects? And so in general, R will kind of create the least common denominator vector. So will not give you an error, but what will happen is that it will coerce the vector to be the class. That's kind of the least common denominator. So here in the first example, I've got in trouble concatenating number 1.7 and a letter A. So clearly these are not in the same class. One is numeric and the other is character. So the least common denominator here is going to be character, and so we are so what you are going to get is that Y is going to be a character vector where the first element is going to be a string 1.7 and the second element is going to be the letter A. So in the second example here, I've got concatenating true, which is a logical, and a 2, which is numeric. And so what's going to happen here is that you are going to get a numeric vector and the true is going to be converted into a number. And so how's that happen? So, and by the convention in R, true is represented as the number 1 and false is represented as the number 0. And so what you are going to get here is a vector 1 and 2. Lastly, this last example here, I am concatenating the letter A and the logical true. And so here the least common denominator is again going to be a character. And so the character that you end up with is a vector where the first element is A and the second element is the string true. So true, it's not going to be illogical. So you need to be a little bit aware of the types of the coercion that can occur in our when you mix different types of elements in a vector, and because you won't get an error, but the coercion will happen behind the scenes. In the previous slide, we talked about kind of implicit coercion that occurs behind the scenes, but you can explicitly coerce objects from one class to another using functions that usually start with the word as dot. So for example, if you want to convert something to a numeric, you can use the function called as dot numeric. If you want to convert something into a character, you can use the function as dot character. Now if you apply these functions, so if you apply as dot numeric to a numeric vector, nothing will happen. So here in this example, I am starting off by creating an object called X, which is a sequence of 0 to 6. So this is an integer sequence, as you could see when I call class on the object, but I convert it into a numeric sequence, and so I can call as.numeric on X, and you can see that it prints out 0, 1 through 6, which look like an integer object, but it's actually going to be a numeric. Or I can convert it into a logical, and so I can say as.logical on it. And what happens, well, as you can see, the convention is that 0 is false and any number that's greater than 0 is going to be true. So here I've got a When I convert to logical, I get false, and then everything else is true. When I call as.character on X, it takes all the numbers and converts them into characters. So now I've got the string 0, the string 1, 2, etc. And finally, if I call as.complex, this is fairly straightforward, because all it does is says that you have a complex number where all the imaginary components are 0. Now Coercion, will notice, always doesn't work, and when it does not work, you get what are called NA values. So nonsensical Coercion will result in NAs. So for example, if I take the vector ABC and call as.numeric, well, there's really no way to convert the letters A, B and C to numerical variables. So what you get is a vector of NAs and plus a warning. Similarly, if you call as.logical on X, you are going to get a vector of NAs. The next data type I'm going to talk about is the list. Now I have mentioned lists a little bit earlier in this lecture, and the idea is that they are like a vector, except that every element of a list could be an object of a different class, and so that makes a list very handy for kind of carrying around different types of data, and they are very useful in R, and they become very common, especially when in conjunction with other types of functions that we are going to learn about. So here I am creating a list called X by using the list function, which can be used to construct the list. And the first element is a numeric value, numeric object of 1. The second element is a character, letter A. Third is the logical true, and the fourth is a complex number. So this is not a problem with lists, and when I auto print the list, you will see that it prints out a little bit differently. It does not print out like a vector because every element is different. So you can see that in double brackets here, the elements are indexed by double brackets. So the first element is the vector 1, the second element is a vector with A, the third element is a vector with true, and the fourth element is a vector with the complex number 1 plus 4 iota. So lists are indexed. You will notice that elements of a list will have double brackets around them. Elements of other vectors just have the single brackets. So that's one way to separate a list from other types of vectors. These slides and some practice material for you to practice will be provided in our blog post. So check that out, and see you in the next lecture, where we will discuss a few other data types in R. So see you in the next lecture.